Okay, I think it's good. We can start now.
Good morning, everyone, and welcome to our presentation today on embodied carbon in the building industry with a focus on fenestration. As most of us in the window industry are accustomed to years of talking about energy performance in fenestration products in the building industry. We've had tremendous advances in the building code. We've got step codes, and we've certainly been discussing window energy performance a lot at Fenestration Canada events. But another topic that has really been gaining attention is the subject of carbon, not just in terms of the energy that we consume in buildings or the carbon content of the fuels, that are used to operate our buildings. But as buildings become more energy efficient, there's now concern that the embodied carbon in the building materials is becoming, as we use less operational carbon, there's more attention being paid to the carbon content of the building materials themselves. And of course, this is a relatively new conversation to those in our industry. We haven't really discussed this topic at Fenestration Canada in the past. So this morning we've invited some folks from WSP to introduce us to the subject of embodied carbon and how it may affect the glass industry and the window industry in Canada. So our guests today are Will Nash, Scott Armstrong, Lizeth Rivera-Sanchez, and Michelle Christopherson. And I guess I'd like to maybe ask you to introduce yourselves, starting with Will, and we'd like you to then start the presentation and help the participants in the Canadian window and door industry start to get an understanding of why carbon is important, what kinds of measures are being used to actually account for carbon, and how that might affect our industry. So, I think we need some view of the global picture, but also it's, at some point how that might affect us. Will, I'll turn it to you.
Great, thanks, Al. My name is Will Nash, and I'm the lead of the materials team in BC. And I guess, part of my role is looking at materials in general, materials durability and materials sustainability, and part of that obviously entails the embodied carbon aspect. Scott, if you want to jump in.
Yeah, Scott Armstrong. I'm with WSP's Façade engineering team. I'm a senior façade specialist. I've been dealing with building enclosures and sustainability for a little over 20 years, and over that time seen this transition to interest in embodied carbon. So I do focus on high performance building enclosures, and more and more these days on the embodied carbon component of both the existing building and the materials that go into building new buildings.
I can jump in. So Michelle Christopherson, I sit in Vancouver on our climate change resilience and sustainability team. I focus primarily on life cycle assessments. 95% of my projects right now are studying not just embodied carbon, but all of the sort of embodied environmental impacts from buildings and infrastructure projects and materials. I joined this team, I came from the building sciences team over on Scott's team. So I have a healthy respect and understanding for the complexities of windows. So to me, this is particularly interesting, an interesting area to look at when we're balancing the operational and embodied emissions. All right, I'll pass it over to Lizeth.
So hi everybody, I am Lizeth Rivera. I sit in Toronto. I am the energy and carbon analyst at WSP. So in my work, I analyze buildings not only on their operational carbon, but also on their embodied emissions.
Excellent. So if we turn to the presentation, so long as, there we go. Right, yeah. So just a quick overview of the agenda that we wanted to talk about today. What is embodied carbon and why do we care? How is it measured? What are the opportunities for fenestration? A little bit about reinvesting in embodied carbon, and then a summary, and then we can open up to having a discussion about, I guess, a relatively new topic to the industry. So when we look at carbon, there's the difference between embodied carbon and operational carbon, and 11% of all global carbon emissions are due to the building industry. And when we look at the whole of the life cycle of a building, and we're accounting for all of the carbon in there, the focus to date has been on this piece in here about the operational energy and the carbon associated with that. But the embodied carbon encompasses these components that run from all of the manufacturing, resource extraction, transporting to the project site, the actual construction activities and the maintenance activities, refurbishment that have to happen. And then at the end of life, some of these aspects here around deconstruction, disposal, and those sorts of carbon emissions that are associated there. And so, so yes, when we look at the total global emissions by sector, the global emissions that are associated with all of these things then come up to roughly 50% of carbon emissions. So why do we care? Well, we know that we've done a really good job of reducing the building operations, as Elle sort of touched on and Scott touched on as well. The operational energy of buildings has been optimized over the years to the extent that now a lot of the global north building standards are practically passive house, or near enough. But these emissions here that are to do with the embodied carbon are taking up a larger and larger slice of the pie. So ignoring those materials, those emissions, is almost half of the problem. And so we know over the next sort of 10 years, we need to take a great effort to reduce the reduce carbon emissions globally. With a lot of the research saying that we need to reduce between 45 to 100% by 2030 global emissions to have a chance of keeping temperature rises below 1.5 degrees. And if you look then at from today to 2030, the embodied carbon of new builds is going to be the majority of that carbon, because it's locked in from the beginning. It's sort of like a capital investment, if you like, of carbon emissions. And those operating emissions then obviously increase year on year. And it isn't until 2035 that operational carbon is expected to overtake that embodied carbon. And this is the time for action right now, where we need to really be focusing. And the other reason we care is that there are a lot of these building standards today that are incorporating aspects of embodied carbon. So in Canada in particular, the Canada Green Building Council has introduced the zero carbon certificate, and this has requirements for reporting and offsetting embodied carbon. The Living Building Challenge, which is I guess increasing a little bit in the number of buildings that are going for that sort of certification, which is probably still the highest standard of certification you can get for a building, and they require reporting of all of the embodied carbon and 100% offsetting. Within LEED 4.1 now, you can achieve up to 9 credits for embodied carbon activities, and then the Buy Clean policies that are being rolled out in the US, and we'll have a map of that. And so when we look at Canada in general, obviously there's, from the federal government, the carbon tax is one aspect, but also the federal government has introduced the Greening Government Strategy, and all new builds need to be net zero carbon. So that includes consideration of the embodied carbon. And then within the province of British Columbia, so we're obviously talking about BC, this is what I'm more familiar with, but all new builds in BC require LEED Gold, which then therefore translates to demands for the embodied carbon accounting. And the City of Vancouver, through their Climate Emergency Action Plan, have committed to a 40% reduction in embodied carbon by 2030. So these are big drivers for us for measuring and reporting and reducing the embodied carbon. And then in the US, the Buy Clean legislation is, it has passed in California, and it is under consideration in these other states, as well as federally. And there's some expectation that the Biden administration will bring in a federal Buy Clean Act. And what that means is that specifications and policies at a local government level, up, from local to state to the national level, will have requirements to reduce their environmental impacts, including considerations of the embodied carbon. And so this will likely have a flow-on effect to the Canadian market for manufacturers that are selling into the US, but also for products that are coming from US manufacturers and competing into the Canadian market. So yeah, Lizeth, if you wanted to take control there.
Could I ask you a question, Will?
Sure.
The Buy Clean, is that carbon specific, or is that a package of environmental improvements?
It's a total package. So it's really looking at policies in general, but they do have, so for instance, some of the early Buy Clean Acts in Washington State and California, they set limits on the embodied carbon that you can have allowed for instance, with cement. So they have the concrete Buy Clean in California that has an upper limit on how much embodied carbon you can have in the concrete. And so those sorts of policies we expect to flow on to other building materials as well.
Right.
Okay, so now let's move to how do we account for carbon? So we do it through a life cycle assessment, or LCA, which is an analysis of a product's entire life cycle in terms of sustainability. But what are actually the steps for conducting a life cycle assessment? Well, to help the industry out, the International Organization of Standardization developed a framework for conducting life cycle assessment. And this framework has 4 main steps: goal and scope definition, inventory analysis, impact assessment, and interpretation. So I think I'm having problems with, okay, yeah, sorry. So for the first step, goal and scope definition, you will define why you are doing the study and what are you going to consider, or what are your system boundaries and what is the functional unit of your product. So for instance, 1 square meter of double glazed aluminum window with a new value of X. The following step is the inventory analysis. This is usually the longest and most labor-intensive part of the LCA. And here, what you're going to do is you're going to collect data. So you will need to quantify what are the material inputs, what are the material outputs, what is the water consumption, the energy inputs, and the transportation distances. And with this data, you will create a model in which all those quantities are translated to emissions, pollutants, energy, etc. So for this phase, there are databases and modeling software such as Tally, Athena, CIMAPro, Gavi, and EcoInvent that will help you throughout this process. Then you will need to perform an impact assessment, which in which the results obtained for the inventory analysis are ultimately categorized into impact categories such as global warming. And finally, you will have to interpret the results and figure out what all those numbers means. So for instance, in this phase, you will define which phase of the life cycle is leading to the most environmental impacts. Is it the manufacturing, or is it the use phase, or the transportation, or which is the material that is leading the most environmental impacts? So as you can see with these arrows, at any point of the process, you might need to go back on an early phase and redefine things. Why? Because at the beginning, you might set a question and then you will realize that you don't have the data, or the data is very hard to get. So you need to come back and redefine your goal and scope. So at the end of all this work, you will like to report your results, right? So a way to do that is through an environmental product declaration, also called EPD. So you can think about an EPD as the nutritional facts label or of your favorite cereal. So in the nutritional facts label, you have a serving size. On an EPD, you have the declared unit. On a nutritional facts label, you have the nutritional components of the product, such as calories, cholesterol, sodium, protein, etc. And on an EPD, you have the environmental impacts of your product, such as global warming potential, which is the impact that accounts for carbon. So EPDs are valuable for the construction industry because they help us to make more informed decisions when selecting materials. However, we must ensure that we are comparing apples to apples. And the problem is that, as you can imagine, there are multiple ways to perform a life cycle assessment of a product. And based on what you select as a functional unit, system boundaries, temporal boundaries, and etc., you can have multiple results for the exact same product. So how do we normalize the life cycle assessment parameters to make sure that all products are considered with the same things? Well, the first attempt to do that is through a PCR, a product category rule. So a PCR is a document that outlines the requirements of a life cycle assessment. And it provides rules, requirements, and guidelines for developing an EPD from a specific product. There are PCRs for many products, such as concrete, windows, steel, etc. Actually, you can find PCR for pretty much everything, and they are developed through an open and transparent collaboration between the industry professionals, life cycle experts, and public stakeholders. So, in a nutshell, to develop an EPD, first you need to find the PCR of the product category. Then you need to perform the life cycle assessment based on that PCR. And finally, you need to report your results as an EPD. Of course, these results will need to be verified by a third party. It's not just that easy. So now, talking about fenestration EPDs, we can see that many manufacturers have already developed environmental product declaration for windows. So you might think, well, that's perfect, we are set, we don't need more. But the problem is that most of them has been done for European products that could have been manufactured with different technologies, energy sources, and materials that we have here in North America. So despite some of the information provided by these EPDs from Europe are useful for the North American construction industry, it is essential to have local data. And this is why it is extremely important that manufacturers in North America develop EPDs for their products. This is a summary of the important documentation that you will need regarding EPDs, LCAs, and PCRs. So now I think I can pass it to Scott.
Thanks, Lizeth. There we go. So as Lizeth mentioned, it's important to have EPDs for local products or products that are manufactured in North America. I know even my own experience, I've worked on new development projects or even retrofit projects where we may be sourcing glass from Spain and fabricating the IGU in the Middle East and then assembling it into a curtain wall assembly in North America with aluminum that could be coming from either US or Canada. And so there's a lot of sources for products in the fenestration industry. We also know that across Canada, the cleanliness of the electricity grid varies very significantly, widely. This is a sort of color-coded map showing the equivalent CO2 per kilowatt hour based on the region. So you can see the darker areas having higher carbon emissions per kilowatt hour. So really, depending on where your manufacturing facility is, or maybe where the smelting facility is, or recycling facility for aluminum, the location matters a lot in terms of the embodied carbon that's going into that product. And then, of course, transportation can't be ignored, and the mode of transportation is important. A lot of products might be coming by rail, but they may also be coming by truck. And the emissions profile with those two different modes is very different. There we go. Oops. I'm not sure what I did there. Let me see if I can go back. You're getting a reverse. There we go. Apologies for that. And also, when we think about the fenestration industry, obviously it's made up, the systems that we deal with are made up of many different components. So there's certainly a virgin material feedstock issue or challenge. We know that recycling vision glazing, for example, is very difficult. There's a whole issue of trying to separate materials, dealing with materials, glass that may be coated or aluminum that may have different coatings on it, not to mention all the sealants and the desiccants and spacer bars, and kind of separating all these materials out to be able to reuse them. And when we were planning this conversation, this presentation, the question came up even within our own team, well, aren't windows a standard size? And we just know that that's not true. I mean, every window is essentially a custom size, even in the single family residential market. And so reusing products directly is also very difficult, if not impossible. You can imagine too that different processes, aluminum, you can have very high recycled content, but vision glazing for that optical clarity, it's very difficult to do that. So the end of life is a big question for glazing units. It's maybe a little bit clearer for framing systems like PVC or maybe even for aluminum. But there's a lot to consider when looking at the feedstock and how that's contributing to embodied carbon. I talked a bit about aluminum, but you can also appreciate too, there are lots of different frame types. So even in this one image, we have aluminum, we have straight wood frame, we have metal clad wood frames or PVC or non-metallic frames. And each of those has a very different embodied carbon or energy intensity profile for its manufacturer. And each one contributes differently too to operational carbon. But we also have to think about things like durability. So how long will the window system last? And we've seen some reports that may be geared or maybe driven by a particular segment of the industry that shows their product in a favorable light based on a certain life cycle replacement plan, which may be skewing the data. So it's important to understand what the expected service life is of the building, service life of the component, what the durability of that product is, what the replacement cycle looks like if you're actually comparing across, say, 100-year service life for a product. And then maintenance issues are not equivalent across these systems. Obviously, I have wood windows on my own house, and I do have to paint them from time to time. But I also have a metal-clad wood sliding door, which has a lower maintenance requirement. But in the grand scheme of things, the maintenance needs to be considered, but the focus at this point really needs to be on developing EPDs and understanding the embodied carbon from the fenestration system at the outset. I want to talk a bit about existing buildings because I see this as essentially this is already spent carbon. Existing buildings represent 50% of the building stock that will still be here in 2050. They incur a lot of operational carbon emissions because they're generally inefficient, although you might argue that maybe modern buildings are not as efficient as we would like or think. And we know that existing buildings do represent a significant opportunity for retrofit. The issue is, though, that this enclosure usually comes to some sort of end of life where we have to do a significant retrofit. Canada Green Building Council, WSP worked with Canada Green Building Council to develop this roadmap for retrofits in Canada. And really it came down to these 4 fundamental points: recommissioning, deep retrofits, renewables, and fuel switching. We're going to focus a bit on deep retrofits because, again, in my experience, we do a lot of existing building work, we do a lot of new development, and kind of the marrying of those two worlds of the newer technology, improved efficiency with this already spent carbon that is currently the contributor to climate change. That presents an opportunity to do these deep retrofits. And although I'll be speaking about the building enclosure primarily, once you start looking at enclosure renewal, that really helps to trigger much larger scale, much deeper retrofits on the mechanical and electrical side, and possibly on natural ventilation side or passive house type retrofits. We know that, again, if I'm looking traditionally at the way we used to look at embodied energy or life cycle analysis, I started doing some of this work. I'm not nearly as deep as the rest of this team in this, but I remember looking at these studies maybe 10 or so years ago, 10 or 12 years ago, and embodied carbon was about 10% of the building's total life cycle carbon emissions. And so these two graphs show maybe a different way to look at that. On the left, the red dots show like a low energy building, and you can see they all have around the same embodied carbon, but they vary significantly in their life cycle energy because they have different levels of thermal performance and operational carbon being incurred. You have at the far right, on the outlier, the green triangle, this quote unquote self-sufficient building, which has very high embodied carbon, but over its life may be lower than some of those kind of conventional or lower energy buildings. We also know that as buildings get taller, sometimes they require more substantial structural frames, and the choice for that framing system can significantly influence the embodied carbon. And you can see those lines on the right graph showing the difference between, say, for example, a steel frame with a steel and concrete floor versus maybe a reinforced concrete frame and a lightweight flooring system. So again, as you go taller, you get heavier. Maybe there are more wind loads. You're increasing the weight of the structure, so therefore you're reinforcing and adding strength to the lower floors. So there's this whole knock-on effect of the embodied carbon in the structure. And as I mentioned, the traditional thought or reality was that embodied carbon was a relatively small portion of the total life cycle carbon emissions for a building. And that's largely because we were living in this kind of conventional world where buildings were operationally inefficient, and we didn't really need to focus a whole lot on embodied carbon because we knew that it was more about operational carbon. But as we push more and more towards this low energy or net zero energy, embodied carbon becomes a much more important part of the picture. And again, very simply, if we sort of use colors and a bit of a graphic to illustrate that, light blue being the embodied carbon, as we push towards these net zero, embodied carbon is all of the carbon for the building. And to Will's earlier point, 2020 to 2030 is our decade to act. And as we continue to deliver lower and lower energy buildings, embodied carbon becomes a more and more important part of solving that carbon problem in the next 10 years. Sorry, it's not advancing for me. There we go. So I have just, again, a couple of slides in quick progression. This notion of reinvesting embodied carbon or reinvesting in assets which represent significant amounts of already spent carbon. So I've just simplified this as showing a straight line graph. It probably should bend up a little bit as operational carbon gets higher and higher as the building maybe starts to leak more or the systems age. But for simplicity's sake, I'm kind of keeping that as a straight line. If at the mid-year, say midlife cycle, say 50 years of this 100-year service life, I incur a major retrofit, but I don't achieve any operational savings, then not only have I incurred additional operational carbon, I haven't changed the ongoing carbon emissions. And so at the end of that 100-year life, I've made the situation worse. I've contributed more to the climate crisis by emitting higher levels of carbon. another way to look at this when we do retrofit buildings is to try to reduce the slope of that graph. So if we can choose the right approaches to the retrofit, which reduce operational carbon, yes, we are incurring more embodied carbon in that retrofit, which is still required for any retrofit. But maybe even after 10 years or after 15 years, that operational carbon is lower than the originally anticipated operational carbon. So at the end of 100 years, my carbon profile is much lower. My sort of big, hairy, audacious goal, if you're a good to great reader, is this notion of a low embodied carbon retrofit. So spending less carbon on a retrofit project and then perhaps delivering either net zero or carbon positive or carbon negative, depending on your perspective, a sequestering approach, so that not only do you incur less embodied carbon at retrofit, you also significantly reduce the operational carbon, or in some cases have net negativity on the carbon, and you essentially begin to sequester past emissions from that same asset. So again, just sort of putting that out there as this maybe stretch goal or big challenge for the industry to pursue these kinds of restorative projects that take this building, which represents a significant amount of both embodied and spent carbon, and trying to reduce or minimize or maybe even eliminate some of those past emission issues from that asset.
So how might one do something like you're saying sequester carbon, or
yep,
in effect reduce the net carbon?
It's a good question.
Consumption of the building, right?
Yeah.
What kinds of strategies might do that?
So I would expect that this is a combination of, so let's take a fairly simple building that might have a well-managed window-to-wall ratio, and you invest in a significant building enclosure upgrade, maybe to the Enterfit level or to like a net zero carbon level. You introduce renewables on site. Maybe you switch over to electricity for any power that you do need, so that you do have a net negative, possibly carbon profile. And then any insulating strategies that you use, maybe you use cellulose products or something else that is maybe low embodied carbon as opposed to some of the higher embodied carbon materials that we're used to. Insulation is an interesting topic. You know, in Canada, we've seen the 2021, as of January 1st, the mandatory requirement for foam insulation products to change their blowing agents. And so what that has meant is that the embodied carbon profile, or the equivalent GHG emissions for rigid insulation, has come down significantly. So it's important to know that this is not a static situation either. It does require a review of all the materials almost for every single project. You can't necessarily just go based on the last project or the last two projects, because the industry is definitely changing. So again, notionally, that's what I would see this looking like, is some retrofit that has a low embodied carbon for the materials, and then maybe integrating renewable energy or passive techniques, natural ventilation, and achieving that kind of carbon negative in operations, or at least carbon neutral, so that, you know, maybe that line just goes flat, right? So that I've incurred a little bit more operational carbon, and instead of sloping down or sequestering emissions, it's not contributing anymore in operation. It's maybe a net zero carbon in operation building.
Yeah, I'm just having a hard time understanding the word sequestering in this context, because you described things that are, you're going to use less carbon intensive materials for the retrofit, and you're going to maybe change a fuel source and reduce the carbon content of the fuel, or eliminate it entirely with solar or whatever. But at this, you're not, where does the sequestering come in? It sounds like,
it's, yeah, you're right. Maybe I'm not using the right term, but I would equate that to, if I'm generating more electricity on site than I'm using, then effectively I'm carbon negative, right? So I may be transmitting more to the grid than I'm using. So it's in that case, I'm taking that as my sort of sequestering carbon, or I'm offsetting someone else's potential carbon emissions by
Okay.
providing
Okay.
to them renewable energy from my site,
Right.
for example.
Yeah.
Just to jump in here, so there are some materials coming on to the market that are utilizing agricultural waste or high rotation crop cellulose that then processed into structural boards and members, right?
Mhm.
And those technically are sequestering the carbon in the building. And there's a whole movement for buildings as materials banks and these sorts of things, and some discussion around those sequestering strategies. So I think if you can take that in concert with what Scott's talking about, there is an opportunity there to really start looking at ways to sequester and reinvest in that embodied carbon.
And we didn't get into it in this particular presentation, but it's interesting. We were just having a tech session on sort of innovative new materials, and there is new material, transparent wood product. So again,
Yes,
I haven't looked.
Got a lot of attention lately.
Yes, yeah, I haven't looked a lot. I haven't looked super close at it in terms of how that might work in the fenestration industry. But again, there's this sort of innovative drive for low embodied carbon materials, which, to Will's point, if they're plant-based, could technically be a sequestration strategy. Again, depending on how much energy it takes to process that material. But being a plant-based material, it is essentially using carbon to grow. So that's the lens in which I'm looking at this particular approach.
Oh, thank you.
So to give just two, again, very enclosure specific scenarios, but also maybe very possible today, and then kind of more future looking. We did work on this this project. It's a 2-tower. It's a commercial office building which was reclad or overclad. In this case, we were able to fully retain the existing curtain wall framing, all the back pans, and obviously the entire structure and anchoring and everything else that's behind it, and then graft on this new skin with a pre-glazed aluminum cassette frame with a new IGU on the front. And in fact, a new insulated back pan that was prefabricated to sort of improve the thermal performance and airtightness of the building. And you can see that, from a window U perspective and a spandrel U perspective, we're seeing significant savings or significant thermal performance improvements for the enclosure. And then thinking a little bit more about that future ready notion of heat waves and additional solar heat gain and the demand for cooling in commercial office buildings or even residential buildings. We were able to significantly reduce the solar heat gain coefficient to help mitigate that future effect of the demand for cooling, which is the thing that in Ontario for sure is putting a stress on the grid. We're seeing that now with the storms in the US, where the electricity grid is not capable of that sort of resilience. So adapting buildings so that they can accommodate that a bit more and keep that load profile a little bit more within traditional norm ranges. And then another example is the Ontario Association of Architects headquarters here in Toronto. This building has been modified a couple of times. The most recent work that we finished here was changing to dynamic solar glazing in triple glazed fiberglass frames. So again, very thermally efficient. We did airtightness testing both before and after retrofit to validate the airtightness of the building. There was a lot of investigation in terms of ice storage or some sort of off-cycle cooling option. The entire HVAC system was retrofitted. And then interestingly, so the roof grid that you see that's sort of suspended over top of the building, this building is about 30 years old. And when it was originally conceived, that roof grid was supposed to have solar panels on it. But because this was, the 80s, solar panels were very expensive. It never got built out. And now, I mean, we've seen such tremendous both increase in solar efficiency, but also decrease in solar costs that they then have now been able to retrofit that and put solar panels up on that roof. So this is a I believe the target is net zero carbon retrofit for this particular building. So taking an existing building, I admit it, it's a low rise, it's a commercial use, but improving the building enclosure, we address thermal bridging, we address thermal performance, air tightness, the HVAC system, and then implemented this renewable system on the roof structure that was originally designed for it. Sort of this beautiful, seeing this project to completion is kind of an interesting, I guess I was going to say end to the building, but in fact, maybe who knows what's next with this. So that's just two examples of, sort of the possible today to be expected life cycle replacement or reskinning of existing buildings to this level of kind of whole building deep retrofit that accounts for enclosure and HVAC and maybe some renewable strategies and air tightness. Will, back to you.
Sorry, just need to unmute. So yeah, I guess in summary there, these are sort of the key takeaways, I think. As Elle, you mentioned in the introduction, there's a bit of a shifting focus now. So the operational energy, that piece of the puzzle is very well understood, and the performance of new builds and retrofits is only getting better to the point where we're having net zero buildings, and so that focus is shifting now from that operational carbon to the embodied carbon. Part of that then is there's evolving expectations from our clients and from the industry, which means that we're expecting to see increasing demand for EPDs of products, including fenestration products. And so beyond that, once we're measuring the embodied carbon in those products, there is an expectation that there'll obviously be a drive to reduce that embodied carbon in buildings. And of course, that is around reporting and transparency requirements, and trying to have whole industry level product category rules, so that we're comparing apples with apples and making sure that everyone's on a level playing field. Some of the opportunities for fenestration, it's looking at where can we get products that have low embodied carbon and that are still providing those high performing characteristics that help us to make sure the operational energy doesn't shoot up or anything like that. And obviously some really great opportunities for reinvesting in embodied carbon through retrofits. And we expect to see going forward that large clients, government clients, are likely to increase retrofits as a proportion of the works that are going on, and their sort of capital expenditure, if you like, because of this carbon issue of new builds really incurring a very large embodied carbon cost compared with retrofits. So that's obviously another opportunity for the fenestration industry to have products that are targeted to that market, which we expect to see increase. And from there, I think we can probably open it up to questions, Elle.
Yeah. Do we have any questions from our viewers, Steph?
Yeah, we have 3 questions here in the Q&A.
Okay, yes, I see them here. So we have a couple of questions from Terry Adamson. Are there any discussions or expectations that we will see regulations or requirements for window manufacturers to provide EPDs?
That's a great question. And I think that there's a couple of things that we can look to provide that response. First and foremost, we're not the policymakers in Canada. So I want to say that what I'm going to say is just based on what I've seen in the discussions so far to date, which is obviously expected. I know that the federal government has a life cycle assessment initiative that a couple of us sit on the panel for, the technical committee for. And what we've seen is that there is a bit of an initiative to get a database set up with Canadian specific EPDs. It's a big undertaking. So this is not something that we anticipate is going to happen within the next 6 months. But we do anticipate that it's coming down the road. And the reason for that is I often suggest that we look at the European market. They're 20, 25 years ahead of us in terms of embodied carbon, and EPDs are commonplace. Most governments in the European Union and Scandinavian governments require EPDs for nearly every product, and they have quite a bit of data available. So I would say that is the down the road, we expect to head that direction. Also, as Will was mentioning, the Buy Clean Acts down in the United States. Those acts typically start, the first starting place when they're brought into legislation is to just provide EPDs. So they require and I will also say this is for public procurement only, these Buy Clean Acts, they start there. That's obviously the biggest driver and where a lot of the financial input, like that's where a lot of the finances come from for starting new initiatives. And so first step is provide EPDs for major products. So as Will was mentioning, there's concrete, flat glass, there's mineral wool insulation, and the first step, understand what the impacts are from the current industry, and then from there they start to develop the caps on global warming potential or embodied carbon. So I would say that based on what we've seen, we anticipate that coming into effect. The timeline is difficult to say, but we have seen the federal government take strong initiatives in this manner, and I would say that it's likely coming. So we should expect that it would be in the future. And then Al, I can just read the next question as well if you want me to.
Sure, if you can see it,
that.
yes.
Yeah, I can. Okay, so the next question, and Terry, thanks for your questions. These are fantastic. So are you aware of any research being done on the increase in embodied carbon for higher performance systems and the reduced carbon impact they provide for homes? And I love this question because this is something that comes up quite frequently in my conversations with designers, building envelope specialists, architects, as well as different contractors and manufacturers. So what we see this sort of tension between, in higher performance envelope typically has more materials if you're talking about insulation, and also in terms of windows, if we're thinking about triple glazed windows, different frame materials that have a higher thermal performance. So oftentimes we see the embodied carbon actually increase in order to get that decrease in operational emissions. And this is where I really love the zero carbon building standard that's come out recently, in that it looks at carbon holistically. So the question of is there any research being done to look at that balance? The research is being done on an academic level as well. Lizeth has actually done her master's thesis in this sort of area, but we're seeing that from a regulation standpoint as well. And I would say that every project that we do is a research project to truly understand, based on that specific project, what is the embodied carbon increase of meeting a specific TEDI target or a thermal performance target. So I would say that data is coming. There's been a big uptick in the zero carbon building standards. So I think we'll start to see the results of those projects and start to have that conversation of, yeah, fantastic, let's make a high performance building, but understand that there is a carbon price tag on that, embodied carbon price tag. But that also opens up the door to looking at the materials that we're using. And just because we're using more insulation, can we not make it a better insulation, a lower emitting carbon insulation? Or looking at window frames, is there possibilities to use different materials, or reconfigure some of the materials a little bit to make sure your thermal breaks are looking. There's so many options, and there's going to be a lot of research in that area. So I would say that over the next probably 3 to 5 years, I would say we're going to really understand this balance with a lot of hard data as we do more of these projects and sort of consider those. And I think that's something that, as an LCA practitioner myself, I always bringing that into the conversation. No one should be doing a life cycle assessment and looking at the embodied carbon through only that lens. We need to think about it holistically and have those conversations, because I think you're right, there is a balance there that we need to manage to make sure that the overall picture of our carbon emissions in a building makes sense. And I do want to also touch on your comment refers to homes. And so that's something we have seen the legislation and building certifications are predominantly for multifamily residential or commercial office government buildings. So most of the research that we've seen to date has been for those larger buildings. It's not specific to homes, but I expect that the same principles will apply, maybe with some tweaks here and there. So I think it'll be really interesting as we get more information and we can see things start to be tailored down towards the more residential market. So hopefully that answers your question. Okay, and then there's another question. Terry, thank you for your questions. This is great. So there's a number of consultants, WSP included, that provides guidance for support looking for better solutions. So this is something that we have, and we're not alone. We do work with manufacturers developing EPDs and understanding what the impacts of their manufacturing processes are. So certainly it's not research that you need to undertake yourself. If you want to collaborate with a consultant on that, there's definitely some benefits in that area. I would say probably the first step is just understanding what your manufacturing processes are, looking at that data. It might be the extent of doing an LCA, and then as Liz was saying, sort of honing in on some of the specific processes or materials that are causing the highest amount of carbon emissions. But there's also some higher level conversations that can happen as well that a consultant can help you understand. There are some less detailed discussions that can happen that I think would probably be helpful. So yeah, absolutely. We can do it. But like I said, there are a number of different consultants out there that could help navigate those steps for you. Any other questions?
I have a question. When it comes to trying to minimize the embodied carbon in the building, you as designers, perhaps Will or Scott, maybe getting involved in the decisions about material or product selection. Are you looking to get a certain % improvement out of every single component, or are you targeting sort of the high value areas? You know what I mean? So you could imagine that steel or concrete are having a huge impact. A window frame, on the other hand, is probably a somewhat trivial impact in terms of the quantity of the material, the amount of actual carbon you're talking about. Glass presumably could have a huge impact, in terms of large areas of glass on a building. So I'm wondering when it comes to something like window frames, are people parsing out and saying, well, this material is better than that material, so we're preferring it just on the basis of carbon, or do you make or do you look at it in a more balanced way, also with respect to cost, also with respect to other attributes, which might include a better thermal performance and so on. So anyway, please, if you could.
Yeah, that's a great question. On that. Yeah, I like that question as well. There's some great questions today. In that, absolutely, it's very critical to prioritize. And so what we do, if we're doing a whole building life cycle assessment, for example, we will do we'll start with a life cycle assessment just to understand where the impacts are coming from. And so we can understand from that model the contribution from concrete, from steel, from all of the materials essentially. And absolutely, at that point in time, we do sort of what we call a hotspot analysis, and we figure out what the biggest contributors are and also what the opportunities for reduction could be. So most of what we've seen so far to date is the concrete side of things, and we've definitely seen a lot of pressure on concrete manufacturers. We've seen them step up as well recently, which is fantastic, to try to reduce the embodied carbon of the concrete. Same with steel, depending on who your steel suppliers are. There's a huge variation in the different steel manufacturing processes, which I think are important to consider. And so when it comes time to windows, they're a little bit tricky, because there's when you're trying to hit different ratings and different performance targets that you're needing to do, and because they are sort of, I would say, likely the weak point in the thermal performance of the envelope, then I would say we I tend to recommend that we look more from the operational side when it comes time to windows. But having said that, we actually do see a noticeable decrease in the overall embodied carbon and other environmental impacts from changes in the window frame material itself. So say if you're switching from aluminum frame, I was just doing a study recently where we looked at the difference between aluminum curtain wall versus the wood mullion curtain wall with the aluminum cap on the outside. And it's a marked decrease. And you would think that it's not a lot of material, so it's a small component, and of course it depends on your window wall ratio. But I would say we focus on the heavy hitters, but we shouldn't underestimate the impacts of all of the materials, and we should look at it holistically, again with cost in mind as well, and how we can fit that into the client's budget, and especially when we're thinking about this more holistically. So summarize, yes, hotspots, absolutely, but we have seen some significant decreases by looking at frame choices, for sure.
Yeah, and I would underpin that to say, as a building science person, Al, you're the same, right? I mean, durability trumps a lot when it comes to carbon emissions. Like if we're building stuff and throwing it away, that's not a productive process. So one of my colleagues years ago, when LEED was first coming out, there was a building that was touted as being LEED Platinum, and it leaked like crazy, right? So there's all kinds of issues with trying to seal the window wall transitions, and that's great. It's great to achieve those things, but unless we're doing so in a durable fashion, then a lot of that effort is kind of wasted, and maybe is undermined, and may lead to higher carbon emissions in the end. So durability, like when I talk about sort of the importance of things, durability for me is always that sort of central pillar that upon which everything else rests, right? So that we're not just throwing stuff away.
Mhm.
Thanks, Scott. Actually, I just want to jump in and say thank you for reminding me about the durability aspect, because when we're looking at a whole building life cycle assessment, it's looking at the whole building life cycle. So we standardize it at 60 years, but we have to look at replacement cycles as well. So as Scott says, if you're replacing something at a higher frequency, maybe it's a lower embodied carbon material, but if you added up the replacement cycles over the life of the building, you'll see that add up. So we really do look long-term, and durability is a huge part of that as well.
Yeah, and executing on that durability, right? Because you can say a window system will last 30 years, but if it doesn't get built well, it's not going to, right? So there's that whole connection of what we expect in the LCA and what actually gets built on site.
I would be interested to look at whether some of like the Accoya acetylized wood treatments for durability, and whether there are any frames out there using that sort of treatment to extend the durability of wooden frames. Because I guess, and I mean, the other thing from a point of view is anything that you have to coat, right? Like you're adding that material on as a coating that then has to be maintained. And the embodied carbon, I don't think is necessarily a very big contributor for that, but it is an ongoing concern. And certainly natural materials, in terms of that don't need any additional coatings, usually are going to be preferred. Anyway, that's my 2 cents.
Right. Yeah. In the durability discussion, I think often the focus is on your primary framing materials durability, but it's very rare that the primary framing structural member is what fails in any fenestration system.
Absolutely.
It's going to be the weakest system, the weakest component in the entire system, and it'll be the weather strips. It'll be the hardware. It'll be the difficulty of replacing glass that's going to trigger the replacement. And I think sometimes the focus has been too much on the primary framing material, with people saying, my material's better, it lasts longer, and not appreciating that, I mean, you look at those lousy aluminum windows from the 70s and 80s. The aluminum and single glazed windows will stand forever, right? They'll be there hundreds of years from now. But what was failing on these windows, the rollers wore out and you couldn't operate the sliding windows. You couldn't easily replace the glass. The frame designs trapped water and caused insulating glass units to fail prematurely, triggering multiple glass replacement cycles. And so you had a super durable framing material, but the maintenance and replacement aspects had to do with some of the least cost components within that system that actually failed early and could not easily be replaced because maybe the existing parts no longer exist because they were so flimsy that we stopped manufacturing them. So when I look at durability, I see sometimes people make choices on windows where the window glass is basically glued in and there's no good way to replace it when a unit fails. Should a unit fail prematurely, you have other window systems that are dry glazed, that are designed. You could have multiple glass replacements over the life cycle of the window frame without a problem. Hardware is often a real problem in operable windows. That is the failure point. That's going to, either mean can you replace it or not? Can you fix it or not? So, sometimes I think decisions are made at the kind of the gross frame level. I'm thinking back to conversations now that I've had with people going back 10 and 15 years on the subject. But it seemed that designers are very preoccupied with, whether fiberglass or PVC is better as a frame material or whether this or that is a better frame material, but not looking at the glazing system, not looking at the other issues. And so I was just wondering how sophisticated the thinking is about durability, in terms of what is it that fails and where should we focus our attention rather than just the structural framing members, which are never the problem. So
That's
I don't know if I've asked a question or expressed a lot of
Not sure. I know. I think that is a fantastic. That's a great statement, and honestly, it does tie into the life cycle assessment. I will say from my end as an LCA practitioner, we don't get into that level of detail, but that is certainly something that our building sciences folks think about. And Scott, I'll pass it over to you to sort of take it from here.
Yeah, for sure. I mean, that is, like I said, that's foundational to our business, right? Durability underpins all of our work, and if we're a lot of that thought process goes into what you said about maintainability and also what small tweaks can we make to improve thermal performance and drainage and replaceability and all these other components. The project that I showed, Richmond Adelaide Center, those are I think 40 and 50-year-old commercial office towers with aluminum unitized curtain wall, very early generation, actually fixed stick built on the right and unitized on the left. And we just bolted a new thermally efficient framing system on top of the old, right? So you want to talk about the primary structural elements, those are 50 and 60 years old that are fine, right? We may have had to do a small anchor upgrade to accommodate a little bit of extra weight, but it's not the primary system that's failing. It's the IGUs, like you said. It's all the exterior. Even the metal panels are chalking and fading, and some of the clips are coming loose. Like all these things that are, foundational to safety and ultimate performance. It's not the primary framing member. So and that's what I like about a lot of these reskinning projects that we're doing is just learning about how much we can keep, right, to both reduce the new embodied carbon, but also reduce the scrapping of material and disruption to tenants. These are all fully occupied buildings, not the OAA headquarters, but all of our, so far, all of our commercial office, these kinds of big reskinning projects or even recladding projects are fully occupied buildings. So again, that's speaking to the resiliency or the robustness of those primary framing members that get to stay in place. And really, like, with curtain wall system, when it comes down to it, it's a lot about that thermal break. So, and that's usually outboard, right? It's not inboard. So doing that retrofit from the outside makes sense.
Yeah. Well, thank you very much. We really appreciate your presentation today. Certainly has given me a broader perspective on this question, and I'm sure to Fenestration Canada members as well. So I'd like to thank each one of you, Will, Michelle, Scott, and Lizette, for sharing this information with us. It's our first carbon-related topic, but I'm sure it will not be our last. And I think it will lead to conversations in the coming years amongst our members in our industry, as you say, as if these EPDs are going to become, the currency of communicating about the carbon content, and becomes, a product selection, a high level, how shall I put it, highly critical part of the product selection process. Clearly, it's going to require a lot of attention from folks in our industry. So thank you very much for spending this morning with us, and we really appreciate your helping us in this area.
Thanks for having us.
Yes, thank you very much.
It's a pleasure.
Great, thank you.
No.
Okay.